Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan, and today I would like to present our physics project, which is EGET, or chemical as electricity generative tiles. So without further ado, let's on to the content. This slide consists of 6 parts, and all of it will be presented by me and my other groupmates. So go first. I will talk about the abstract. The first one is context and purpose. As we know, as global energy demand grows and environmental issues increase, we know that the need for sustainable energy solutions has become critical and very crucial. This project focus on developing electricity generator tiles, or we call as EGET, which convert mechanical energy from human motion or human activities into electrical energy. Uh, Using the piezoelectric effect, these tiles generate alternating current, or we call as AC, when pressure is applied or force is applied to the tiles. And then the pressure will be converted into direct current, DC, with rectifiers, and store it in capacitors for use. So what concept that we use in our project? The project involved designing a system with piezoelectric sensors, rectifiers, capacitors, and LEDs to show energy output. Testing involved applying different pressure levels to assess energy, conversion, and storage. We also use tools like MATLAB and Excel to analyze voltage, current, and capacitor efficiency. We also did some research on the concept that we use to produce or make our physics project, and based on our research from the past experiment, the results showed that the EGET system effectively converted the pressure or the human motion into energy, making it a good option in order to reduce energy waste in a busy areas. Uh, Apart from that, capacitors help store the energy efficiently and also provide a reliable output for small advice. And the last one, conclusion. Physics concepts like DC generation and energy storage could contribute to sustainable energy practices. Other than that, the EGET system offers an eco-friendly way in order to reduce reliance on non-renewable energy sources.
So, I am Muhammad Aiman will present about our project introduction. So, the e-gate or electricity generator tile is an innovative solution designed to convert kinetic energy into electrical energy. When pressure is applied to the tile, such as stepping or pressing, it will generate electricity that can be stored or used directly to turn on small devices. These tiles are designed to slightly displace vertically when someone walks on them. This vertical movement results in rotatory motion that generates electrical energy. So for our electricity generator objective is we want to utilize waste energy from human movement in public space, homes or workplace to produce usable energy. Next, our objective is to contribute to environmental sustainability by using an alternative energy source instead of using non-renewable energy.
Assalamualaikum and a very good afternoon to Datuk Umar and fellow friends. My name is Ahmad Uwais and I would like to present about methodology of our project. First, we need to know the 4 key components for this project, which is piezoelectric sensors, LED, capacitor and rectifier circuit. Next, moving on to the step to build electric generating tiles, which we already discussed before. There is 5 steps to build electric generating tiles. The first step is in building the electric generating tiles is to design the overall system layout. This includes determining where the piezoelectric sensors will be placed to capture the most pressure efficiently. Additionally, a detailed circuit diagram is created which incorporates the piezoelectric sensors, rectifier, capacitor, and output devices such as LED. This step ensure that the project has a clear blueprint before moving into the construction phase. Next, the necessary materials and components are selected based on their functionality and durability. Piezoelectric sensors are chosen for their high sensitivity to mechanical pressure. A rectifier circuit is selected to convert ties alternating current generated by the sensors into direct current. Capacitors are used to store the generated energy, while durable materials like polymers or metals are selected for the tile base to withstand continuous pressure. After selecting the components, the piezoelectric sensors are installed beneath the tile. These sensors are secured using strong adhesive or mechanical fasteners to ensure they remain in place under constant pressure. The placement of sensors is carefully distributed to maximize the amount of energy generated with each footstep. Once the sensors are installed, the electrical circuit is assembled. The sensors are connected to the rectifier circuit using conductive wires to transfer the generated electricity. The rectifier is then linked to the capacitor to store the energy in direct current form. An LED is integrated into the circuit to visually display the energy output, showing how much power is being generated by the system. Finally, the system undergo truth testing to ensure it operates as intended. Pressure is applied to the tiles to simulate real-world foot traffic, and the voltage and the current output are measured. Any inefficiencies are identified and adjustments are made to optimize the system performance. This could involve recalibrating the rectifier, adjusting the capacitor, or improving wiring connection to enhance energy generation and storage efficiency. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf Afish bin Azman, and I will explain to you about the results and discussion. So firstly is the energy impact. The EGET can actually conserve almost 1 to 5% of energy, which means that we can replace 1 to 5% of our daily electricity with the electricity that is generated by the EGET. Secondly is the usage. The EGET is perpetually active, which means that it can work all day and all night. So by this, we can ensure the continuous functionality without worrying about the frequent maintenance or interruptions, making it very reliable on generating energy. Thirdly is the location. So the most suitable place to place the EGET is the area with high footsteps, such as high school and airports, because these places have high footsteps, which means that the EGET can be activated many times, lead to more energy generated. So since the EGET generated only small amount of electricity, the device that the EGET can power is only the device with low demand of electricity, such as LED lights, sensors, and signs at the shops or road signs. So let's move on to the limitation. Firstly, the EGET generates only a small amount of electricity compared to other generators because it depends on the pressures applied. Secondly, the efficiency of energy generation is low since it depends on the pressures applied. What do I mean by that? What do I mean by that is the energy generated is high when the pressures is frequently applied, but the energy generated is low when there is low pressure and when is less pressure applied. The third one is the EGET can only be used to power low energy devices. Since the EGET can only generate a small amount of electricity, it is not suitable to power high demand electricity devices such as televisions. So we can use the electricity that is generated by the EGET to power low demand electricity such as LED lights, sensors and signs. So lastly for me is the benefits. So the first benefits of the EGET is that the EGET is a new way of generating a green energy that does not require fossil fuels because there is no chemicals or fuels that is needed during the process of generating the energy. This this can lead to a better environment. Why is that? Because there is no harming substances released to the environment during the process of generating the energy. The second benefits is that the EGET can work at any time, day and night. Like I said earlier, the EGET is perpetually active. So this means that it can work all day and all night without requiring someone to turn it on or turn it off. And lastly, with proper installation and maintenance, the EGET can have a long lifespan which can benefit the owners since it can save them a lot of electricity and manpower. Thank you.
So to conclude this video, the EGET electricity generator tile effectively utilizes human kinetic energy in public spaces, homes or workplaces to generate usable electricity, contributing to environmental sustainability by offering an alternative to non-renewable energy sources. By harnessing pressure to piezoelectric sensors, the project is expected to generate measurable amounts of electrical energy, showcasing its potential as a viable, eco-friendly solution for small-scale power generation and emphasizing the importance of sustainable energy innovation.
Okay, so as the representative of my group, I extend my deepest gratitude to Dr. Umai, the lecturer at University of Malaysia, Physics Division, Center for Foundation Studies in Science, for his guidance and encouragement throughout this study. His support and expertise have been invaluable in ensuring the success of this research. I also would like to acknowledge the faculty and staff in the Center for Foundation Studies in Science at UPM for their invaluable resources and assistance. The support was pivotal in the successful completion of this project. Last but not least, special thanks to my group mates and classmates of Kuliah 18 for their teamwork and the stimulating discussions that kept me motivated. Their collective wisdom and encouragement have been a cornerstone of my academic journey. So that's all from our group. Bye.